All right, hello everybody. How goes it, everybody? How's everybody doing? Yeah. Hello, hello, hello. Hello, Gerda. How are you? All right. I'm doing well, JTS. I'm doing well, my dude. How are you doing? How was your weekend? How was everybody's weekend? Um, hopefully everybody was hopefully everybody is doing well. Are those knowledge checks? No. Those knowledge checks on Alex are not required. No. If you want, they're just supplemental problems at the end of the day. You can focus on the homework though. I mean, they talk about basic concepts from before, so the only reason why I don't I don't recommend them too much is because they talk about previous concepts. When in reality, you want to focus on the concept at hand. So if the section's about matrices, then you want to focus on matrices, not stuff you did before. Wow, that's rude. Normally I would say JTS. Normally I would say take a chill pill, but I'd be like, bro, take a vaccine. I'm pretty sure it'll help. that's how I would feel. Hey, PS5. Hey, Gerda. That is nice. Very nice. Hopefully that's a significant difference from the PS4 there. Obviously it's much better hardware. But let's see how the I want to see the performance there. See if it is by far and away. PC is the master race. This is true. All right, I have runs faster and is a lot quieter. So see, we even my commands agree. Commands totally agree. I have a RTX 2080 Super. I've shown you guys my computer, right? Haven't I? I don't remember if I showed you my computer or not. No? Okay. Um, yeah, I can show my computer here. Kind of what this thing's running off of. So, probably wondering kind of what's behind the scenes a little bit. My place is still a bit of a mess. So, I got some garbage to throw out eventually. So, come on. I'm giving up on that connection stuff until crap comes in and takes care of it. So, oh, 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 there we go. Yeah, stream is a bit laggy because of my connection stuff. So, you'll kind of have to pardon me here. Very, very laggy. I ain't gonna lie. As you know, this thing's gonna as you know, this thing does lag out quite often. Use spike up, spike down, do things. Uh, no worries. All right, hopefully this works. Okay, well, hopefully it settled itself out. My connection's notorious, so like I said, I just have to worry here. Let me hang on a sec. Stuff. All right, there we go. We got it. All right, so if you guys have never seen my computer here, this is my computer right here. That med's out of the way. So here's my computer. It's got the nice. Let me put it on its side here. Whoop. All right. I don't wait. That doesn't do anything. I'm so bad at this. Okay, let me put it on the full face cam here. There we go. That's a lot better. So here's my computer. It's got RGB fans here on the front. That's my part of my radiator. And then in here is my my RTX 2080 Super. No, the fans are super quiet. They don't make noise. But if I do enter stuff into like the let's say I enter stuff into the chat like hello, you take a look here and then you can see that my my fans will change color. So I got all RGB. You'll notice here that everything changes color. Woohoo! Yeah, baby. Even my keyboard. Again, let's go to my keyboard here. Keyboard here will it'll ripple colors. So there you go. Woo! I gotta set it up in that way. Oh no, it just looks nice to change colors every keystroke. So yeah, it was a bit better from the up top here. Yep. Yeah. There you go. Good stuff. How much was the whole setup? Yeah, the whole setup, man. Because I mean, I upgraded my old video card here, so and the case is new. But if I were to put this together from the base cost, yeah, probably like 25 to 3. So 2,500 to 3 grand. Probably how much this cost here. Many of the parts in this box here I got were from like the motherboard and stuff is over 5 years old. So same with the CPU, of course. But most everything and the RAM. So is that a Mr. Clean ad on that poster? Oh, you're talking about my poster here. No, this is I watch wrestling. So this is a poster of Orange Cassidy, whose nickname is Freshly Squeezed. So yeah, that's Orange Cassidy there. I love Orange Cassidy. So um he ain't bald like Mr. Clean. I could guarantee you that. All right. Orange Cassidy, pretty cool, pretty fun. So yeah, this is my current setup as it is. As a brief glimpse, hey, you're more than welcome to ask questions. So there's not much in here that I can really hide anyway. I'm like, oh, there it is. So yeah, that's my box. It does things. You guys were curious, so 2 monitors. Yeah, 2 monitors for now. So I probably will replace my older one. This is my older monitor here. It just runs at 60 hertz. This is my Predator monitor right here. Um, so this is my main monitor for now. and it can run in 4K glory if it wants to. And I can overclock it to 165. I have a third. I have my TV sitting in my closet, but I don't use that obviously. So yeah, it's here. Boop boop boop. There we go. I think that'll be okay. All right, so this will be here. Excellent. All right, good stuff. So yeah, there you go. Now you get a good chunk of the actual setup here and how I conduct things. So hopefully that isn't too bad. Try and keep things as easy as possible. So nothing too crazy. If you guys got any other questions, feel free to ask. So yeah, more parts are definitely worth it. Cyber Monday is not bad, yeah. I agree. Cyber Monday is pretty good for sales. I'm waiting for the I may end up upgrading my board here. It's an Intel board, but I may end up upgrading over to an AMD board. So because if AMD's to be believed, and I think it is, yeah, the AMD has pretty much surpassed Intel at this point. So, which I thought I would never say in my lifetime, but they've done it. So there you go. Do I think there'll be mobs swarming into stores? No, I don't. I think most people will shop online. I think Black Friday will be focused online rather than be focused at retail. And that's because stores will probably take precautions and they probably will limit the amount of people that can come in on Black Friday anyway. So it wouldn't make sense to hold the sales in store. It'd be an absolute disaster, an absolute health disaster. So you promote your sale online. You say, hey, I'm going to ship it. If you want the Black Friday deal, you do it. You do it there. Yeah, but okay. To be fair, Menards has a perpetual 11% off sale. So I mean, that and Menards are typically much bigger. So in terms of floor space, Menards is ridiculously big, but other stores can't get away with that. So Menards is kind of an unusual case since it's more of a warehouse store. Yeah, I agree. Morning measures, some will be, but they are going to have to monitor how many people can come in because they're going to get in a lot of trouble if they don't. You got to be careful about that. Any other questions you guys have? You guys can ask me whatever. Otherwise, I'll move on here to the thing, to the material. Yeah, I have a timer on the bot. So I have a timer on Nightbot. So it's based on how many lines are put out. So I can extend that if you like. If you do you feel it's too annoying, then I can extend that. That's really not a problem. Your employer had never cared. Yeah, unfortunately. No, it wasn't something you said. It's supposed to be there on purpose. If the stream ever gets bigger, like, I've had like 300 people in a stream before, because it got rated that one time, then at the very least, then I'll know the rules. Plus, it's an easy way for to remind people to participate. So, because this channel is just for mostly classes and whatnot. So, Nah, if you said something really bad, then yeah, then maybe I'd have to ban you. But I don't ban students. You guys have paid for the course, so I'm not about to ban you for that. Maybe put you in a timeout though. You can go to the timeout corner for a while. Mm. That is not happening, my dude. I'll draw horses all day. In a way, kind of. Gerda. But again, if you act bad, I'll time you out, and then you can't say nothing for a while. Always horses. I have no desire to time you out, and I know you. Everybody here is an adult, so I know that they'll act accordingly. So you guys have been super respectful here in the chat, so it's not like I'm going to sit here and say, "Oh, you guys are doing this, that, and the other thing." All right, we gotta get started here. Let's get going here. All right. Okay, let's get started today. Right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you have a nice weekend. All right. So today, we are going to be hopefully getting through this section here in chapter 6. Let me check something here really fast. Okay. All right. All right. Yeah. I'll switch off that. So, okay. We're going to be talking about more about matrices. Okay, so that's what's on the docket here for today. Last time we talked about how to reduce matrices down and solving for x, y, and z. We used the calculator pretty extensively for that, and of course we talked about inconsistent systems, which was talking about no solutions there for a system of equations, and also a dependent system, which is again another way of talking about infinite amount of solutions and how to express that. Um, will we be using the calculator? Yes, we will be using the calculator. That's yes. We'll tell you that. But we have a couple of things that we'll need to cover before we get there. So, all right. So today, what we're going to be doing is we're going to be talking about the latter half of this handout here, the 6263 handout. And so we did talk about, again, inconsistent and dependent systems. Today we're going to be talking about adding and subtracting, multiplying matrices by a regular number, and then multiplying two matrices together, okay, in this particular section. Now, let me check something here. I need to actually see something very important, actually. Uh, hmm, okay, that's perfectly fine. All right. So I'm going to want to leave it up to you here. 1, 2, 3, 4, 5. Okay, good. All right, just want to be sure. I want to leave it up to you here for today. I am going to ask a little bit of a question here. Would you like to do one section or two sections? You kind of have the option here. So we have, I'm going to, like I mentioned here before, we're going to probably skip chapter 8. So chapter 8 will be, I'll probably just negate the homework for chapter 8. So that won't be, you don't have to do that. We'll go up to through chapter 7, which only has 3 sections here. So pretty much technically after this section, we'll have 4 more sections to go. Okay, so there's 6-4, which is the last section of chapter 6, and then 3 sections here of chapter 7. Okay, so that's what would you guys like to do here? Go ahead and put 1 or 2 in the chat. Whichever way you want me to go, I'll go with that way. Okay? So just put a 1 or 2 in the chat. Which way you guys want me to go? 1 section today or 2 sections today? Hager says 2. 1 from Fidel. All right. I got 1 and 1 here. So how many sections? 1 section or 2 sections here? Again, type 1 in the chat, 2 in the chat, okay? Good, all right? Anybody else want to chime in here? Everybody has a vote here. It's in the class, so. Okay. Anyone else? I have Andre and Jenna. If you guys want to vote, you can. So. Okay. Andre, oh wait, we got 2 here. Okay, so we got 1, got 1, 2, 3, 4, 1, 2, 3, and 4. Okay, so we have 4 votes for each. We got a split right down the middle. All right, so let's take a coin flip here. So coin flip, I got a coin. Whenever it's a tie, we do a coin flip. All right, so heads will be 1 and tails will be 2. And then we'll just go with that. Whatever the coin says, that's just how it's gonna have to be. All right, so let's see here. Heads or tails. And it's tails. All right, we're doing 2 sections today. All right, so that's the coin has spoken, and I'm running with the coin. All right, so 2 sections here today. We'll get chapter 6 done then. No problemo. All right, so let's talk about number 4 here. All right. All right, so let's talk about number 4 here. How do we add or subtract matrices? Okay, so when we talk about matrices here, it's really, really simple to add or subtract matrices. Let's take 2 matrices here and let's add them together. Do I want to? No, actually, you know what? I am gonna use the paint tool here for this. A lot easier for me to use a paint tool because it's easier for me to write out examples. All right, so let's look at question 4 here. How do we add or subtract matrices? Let's take an example here and we'll do it straight up. So let's say I have 3, -1, 7, and 9. Let's say I add -9 to -3 and 4. Okay, so again, just making up numbers here as it goes along. Okay, so adding and subtracting matrices is really, really super easy. Like it's very easy here. What's the key here in adding and subtracting? The key here is to add or subtract the numbers with their respective counterparts. So I'll put it this way. The easiest way to kind of do this is, yeah, exactly, Gerda, that's correct. So all we're doing here, super, super simple, is that the first number gets added with the first number, so 3 plus -9. So, all right, and here in the next one you get -1 plus 2. Again, just adding these guys together here. And then here you have 7 plus -3. Again, just add in their respective numbers wherever they match up. Just add those numbers together and finally get 9 plus 4. All right, and then if you put that all together here, you're going to get your final result here of exactly as Gerda said, -6, 1, 4, and 13. That's essentially all you have to do for adding and subtracting here, respectively. So here's another way to add, like if we talk about subtraction here, let's say I change this up here. Let's say I have let me make this canvas a bit bigger here, and then we'll look at that example. All right, so let's say we have the same 2 matrices here. This time I have 3, -1, 7, 9. Again, I have the same thing here, but this time I subtract. Again, -9, 2, -3, and 4. Again, the only difference here is that instead of plus, I just replace that with minuses. And then, of course, I have to change the signs there appropriately. So I had 3 minus -9, -1 minus 2, 7 minus -3, and 9 minus 4. I probably need to change that. Let me check that. I guess I'll have to finish. Yeah, I guess I'll figure out Nightbot at some other point. Yeah, I thought that. I think I have to do that after. Oh, maybe not. Maybe I can do it. Oh my god. Okay. There we go. And let's put every. Yeah, that's fine. There we go. I just turned that off, so it's not like spamming too much. Okay, it's not to turn it off, but again, I just put the timer as double, so that's fine. All right, so if we put this all together here, what we get here is our final result here of 3 minus -9 is 3 plus 9, so that's 12. Here we get -1 minus 2 minus 3. 7 minus -3 is 10. And 9 minus 4 is 5. So very, very easy here to add and subtract matrices. There you go. Super simple. Didn't take us a long time to do. Easy peasy lemon squeezy. All right. Questions about that? That's all a number 4. That's all I got to give you. No questions? All right. Let's move on. All right, next question here then. Next question is, how do we multiply matrices by a number? Okay, this one is also equally as simple. All right, all we have to do here is let's take a look at another example. This is for question 5 here on the handout. So we're going to go ahead and make up another matrix. Let's say I have 3 times the matrix here of -2, 5, 7, and -3. Well, all we have to do here is simply go ahead and multiply everything by 3. So again, super intuitive. 3 times -2. Here we get 3 times 5 here. Here we get 3 times 7 and 3 times -3. And we just go ahead and proceed to do that. Simply dimply. And so here we get -6, 15, 21, and -9. And so don't forget here that you can go ahead and probably combine these together. Okay, so like for example, you may see a problem like this. It's like, okay, if you have 2 times a matrix here, 1, 2, 3, 4, for example, and you could have this minus another matrix here of 4 times -5, 6 -7 and -8 or whatever. Okay, now if you had something like this, again, if you're adding, say, these two matrices, you're multiplying first and then you add the 2 matrices here together. So what you get here is, again, 2, 4, 6, 8. And then you can add that to just multiplying by -4 here to everything. Or again, you can just subtract as well. I don't think it really matters which way you decide to go. Honestly speaking, it really doesn't. Let's make this a minus just to kind of showcase that a little bit. So we multiply 4 by everything, get minus 20. Was this 24 minus 28 and minus 32. So by subtracting this, you could get, this is kind of the long way, I know. I know this is the super long way, but just showing casing how this works. So you could add, you can change all these signs to pluses. So we get 20 and minus 24, and you get 28 and 32. Add the respective numbers here together, and we get our final answer here of this matrix together. 2 plus 20 is 22. 4 plus minus 24 minus 20. 6 plus 28 is 34. 8 plus 32, 40. Okay, so this is our resulting matrix here after everything is said and done. Okay, not very hard to do, as you can clearly tell. It's pretty much doing some simple work, and that's it. Yeah. Any questions about that? So hopefully that's pretty standard and pretty straightforward. Nope. Alrighty. So you can see that one question took me all of 6 minutes. All right, 6 minutes to explain everything. All right, super fast. All right, that's how easy those questions are. Super easy. All right. Now let's go to the meat and potatoes here of what we want to focus on, which is the next question here on the handout. So let's go to that next question right there. That's the toughest one here from this particular section. It's number 6. How do we multiply a matrix by another matrix? I'm going to multiply a matrix by another matrix. Now, what I'm going to do here is I'm going to show you two matrices here. And we're going to multiply these two matrices here together. We're going to do it two ways. We're going to showcase it doing the manual way, and I want to showcase it, of course, doing it the calculator way so we can find our answer appropriately. Now, the issue is that why am I going to show you both when we could just like, well, just use the calculator, we could just automatically find the answer. Well, it doesn't work as easy as you thought it does. And it's not how to set up matrices in our calculator that really is the issue. There is one very subtle detail that we do have to be very careful about when multiplying two matrices together. So I'm going to make a little bit of a contention here, and I'll show you what I'm talking about. So let's say I have two matrices here. I'm going to label it as matrix A. What question was that again? This is question 6. Yeah, number 6 here. All right. So let's say I have matrix A. Let's say matrix A here is -2, 3, 5, and minus 4. And let's say I have matrix B here. Call it matrix B. And let's make this matrix here as -1, -2, 7, and 11. Oh, let's add a few more numbers, actually. I don't think that's such a bad idea. Let's put a 0 here and a 4 here. Why not? I think that sounds fine. All right. I think that's okay. All right. Now, what we're going to do is we're going to take matrix A and multiply it with matrix B. All right, so let's multiply it. We're going to take A times B. Now, you're probably saying, whoa, time out. You're making the contention that I can multiply something that is one matrix and I can multiply it by this other different looking matrix. And as you can see here, A and B are very different in shape, most definitely, compared to other things. Like if we had two 2 by 2 matrices, sure, multiplying those are fairly easy because they're the same size. But in this case, they're not the same size. In this case, they're very different sizes. Now let's take a look at the shape of each matrix here specifically, okay? Because what actually happens here is where the subtlety actually lies. So can anybody tell me, let's look at letter A, okay? What is the shape of that matrix? How many rows and how many columns is matrix A specifically? What kind of matrix do we have here? Do we have a 1 by 3 matrix? Well, what kind of matrix is matrix A? It's a 2 by 2 matrix, okay? So this matrix here is a 2 by 2 matrix. That is correct. All right. All right. What about letter B? What's the shape of that matrix? How many rows and how many columns? B is 3 by 2? Think again. Rows by columns, not columns by rows. Yeah, it has to be a 2 by 3. So again, we have a 2 by 3 here in this case. All right. Remember, it always goes rows by columns, right? So we get rows here, and we talk about columns here. In rows and columns. That looks terrible. Nope. Okay, now let's talk about the steps here on how to actually solve for multiplying these two matrices, because I'm going to make a pretty bold contention here. I'll be like, yeah, I can actually multiply these two matrices here together. I'll make a contention that is absolutely 100% verifiably possible. All right, but before we show exactly how to do that here, we needed to confirm exactly why that happens. Okay, so I'm going to go back to the Word document here for just a second, and that's the wrong one. That's what we're doing for the second section here. But I need to talk about the steps here specifically. So let's talk about the steps here specifically. So I'm going to write out the steps. All right. Step one. Step one here is to basically confirm if you can multiply both matrices together. So there may be cases where we're not going to have the luxury of multiplying those two matrices together. And I was saying, well, wait a second here. How do I know that that's the case? So in order to confirm, you must have the same number of columns in the first matrix and the same number of rows in the second matrix. Okay? So this is actually leads up to two very important points, actually. So this does have significant value here in step one just by itself. We have to confirm whether we can multiply the two matrices here. So again, let's read this carefully here one more time. All right, so that way it's pretty crystal clear. We have to have the same number of columns in the first matrix and the same number of rows in the second matrix. So I need to focus on here specifically. I have 2 columns here in the first matrix, and I have 2 rows here in the second matrix. If these two numbers here specifically, according to step 1, if these two guys are equal, we're good to go. All right? These two guys are good to go. All right? Now, this does have further implications. Let's talk about what those implications are. The second thing that falls out here is if those two are equal and we can go ahead and multiply them with each other, then what we do next is we basically can see what the resulting matrix is going to be. Okay, so let's go ahead and put here a note. The resulting matrix is the number of rows from the first matrix and the number of columns in the second matrix. So if we look here, and I'll put that in purple here. So if we look here at these two guys in purple, just going to underline this. So this is the shape of the resulting matrix. So my resulting matrix here should be a 2 by 3 matrix. Okay, so that'll be an automatic given. Says, okay, what should my answer be? Well, I should have 2 rows and 3 columns for my final answer. All right, that seems fair. All right. Now I'm going to put one more note in relation to step 1. And this is going to be very important here, especially what we'll see in the next section as well. You'll see exactly where that kind of drops in. The next important part here that we have to acknowledge here because of this fact is that order matters. Whatever matrix comes first and whatever matrix comes second has a big influencing deal on if we can multiply or not. So it does matter which matrix comes first and it does matter which matrix comes second. Because if we do like matrix A times matrix B, that'll come out to some answer. But matrix B times matrix A does not equal the same answer. The order matters here quite a bit. So it's not always true that it's not going to be true where again the first matrix times the second matrix is going to be, if we flip it around, you're going to get the same answer. That is not true. Okay. So AB, I'll put it down here. Matrix A times matrix B does not equal matrix B times matrix A. Okay. So we can take that to the bank as well. That's why step 1 here is actually rather important. All right. Okay, step 2. Step 2 is the other step here in part of this process, and we're going to go slow over this part here. That way you can see this in action. Step 2 here is to basically multiply every row by every column and add the results together for each one. Okay, so we're going to take every row and every column. So again, row by column is basically how I'm going to say this, row by column. Now you're probably saying, hold up a second. We have to multiply every row by every column, add the results together, and that's what you put in that particular spot. Now you're probably saying, well, time out here. That sounds rather confusing. And I would say, yeah, when you first do it, I would be like, yeah, I'm not going to disagree. All right. Let's take a good look here and let's see what we can do here in terms of just doing this by hand. All right, so I'm going to go full screen for this one here. All right, and I'm going to kind of show off here how this is going to go. Again, we know what our resulting matrix has to be. Our resulting matrix has to be a 2 by 3 matrix. Okay, so we do have an expectation already on the table. Now what I'm going to do here is I'm going to go ahead and erase this out here. And I'm going to show you how to do the multiplication here by hand. And you'll see exactly how, why this works out the way it does. now let's talk about step 2 here, because we've already determined that step 1 it's valid. Okay, so I'm going to go row by column. So I'm going to have row, first column. So first row, first column. So the way it'll work out is I'm going to multiply each number in its respective row by each one of these guys in its respective column. So I'm going to have -2 times -1. And I'm going to add that to 3 times 7. So I've done row by column, first row. In the resulting matrix, it'll be the first column and first row. Let me go ahead and show off another here. Now I have the first row, second column. So again, I'm going to work in this first row, second column, so it should go right here in our 2 by 3 matrix. So I'm going to have -2 times -2. And then I have 3 times 11. So I'm going to add those together. Just like so. Now I have the first row, third column. So I'm going to focus on this spot right here. So I'm going to have -2 times 0. Plus 3 times 4. Again, row by column. Make that a bit more clear here. Okay. Are there any questions so far about how I found that first row? I want to go slow over this part here, so hopefully it's clear about how I found those, why I put those numbers in those particular spots. I know I admit that the first time you do this by hand, it can be really confusing, so which is why I actually go super slow on this one. Any questions about this step so far? Okay. Let's look at the next one here then. Okay. So we have the second row, first column. So second row, first column here. So second row, I have 5 times -1 plus 5 plus -4 times 7. Now, here's my point of contention. My point of contention is that you may see a pattern here about how I'm writing this out. I hope you've been paying attention here very carefully. I've been writing out the work to this problem here very, very carefully. The reason why I'm doing that here is because it makes these calculations significantly easier. You notice that I put -1 and 7 in parentheses. I did that on purpose because -1 lines up with this -1. Again, 7 lines up with this 7 because it's the first column. Notice we have -2, -2, -2, and 3, 3, and 3 because that was from the first row. That way I can organize myself and I don't have to guess where the numbers need to go for every single spot. What I put in parentheses is what comes down. And what I have here to the left is what goes across. So parentheses comes down. And what comes across? There you go. So I didn't even need to guess on where these numbers need to go as soon as you see that definitive pattern. So that's actually why I actually write out that first row that way. And then I'm like, okay. And then I can write the first one down. And I'm like, all right, well, the rest of them are going to be pretty much where they need to go. And there you go. Notice I didn't even have to really look too hard to know exactly how to add these numbers here together, which is fairly convenient. Now, if we go ahead and put these together here, I have -2 times -1, which is 2, plus 21, which is 23. -2 times -2 is 4. 4 plus 33 is 37. -2 times 0 is 0, plus 12 is 12. We got -5 minus 28 minus 33. -10 minus 44 minus 54. 50 minus 16. So here's our answer for multiplying these two matrices here together. All right, 23, 37, and 12, minus 33, minus 54, and minus 16. There we go. Are there any questions about that? Any questions at all? No? Okay. So we have the answer here that we got, not Pisman called. So we have the answer here that we know for a fact should be A times B. Now, let's try it on the calculator here, and we should net the same exact answer here. Remember, though, that we have to define each of these matrices here appropriately, and we have to put it in the correct order. So again, you should have matrix A here be a 2 by 2 matrix, and again, you should have matrix B here by a 2 by 3 matrix. Okay, so again, go to your matrix menu here. Again, the second key and the x to the minus 1 key on your calculator. Scroll over to Edit, and then go into matrix A. Modify it to make it look like a 2 by 2 matrix, and plug in those numbers. Okay, got it working, nice. Okay, now, one very important part here, remember, you want to quit out of the matrix. Once you have matrix A, hit second and mode to quit to the main screen, and then go back to your matrix menu here again. Again, the calculator here is very particular. If you accidentally enter something wrong, it'll spit out an error, even though you can multiply these two things together. So I always quit to the main screen and then edit matrix B here as a 2 by 3 matrix. Okay, so be very careful. The calculator is very touchy about certain things, and that's one of them. Could you catch me up? We're just going ahead and multiplying these two matrices together. So go ahead, Gerda, and hit the second key and the x to the minus 1 key, okay? So the second key and the x to the minus 1 key there. So what you should see on the very top there is you should see let's see, you should see names, math, and edit. And you want to scroll over to edit and edit the first matrix, matrix A, into the 2 by 2 matrix that you see up there. You'll need to define the shape and then put in the numbers there in their appropriate places. You'll want to, once you put in the first matrix there, quit back to the main screen, repeat the process here, going back to your matrix menu, and edit the second matrix, matrix B, into a 2 by 3 matrix, and then plug in the values in for that matrix as you see on the screen. And we'll go ahead and hit second and mode to quit to the main screen here again. Now we want to bring up both matrices. How do you return to the menu? Go ahead and hit second and mode, the key right next to the second key. That'll return you to the main screen. Then hit second and X to the -1 key again to go back to your matrix menu. So you're just going to do it in small steps, okay? Yep. So we want to go ahead and second and back to your matrix here. You want to call upon name, which is letter A. And you want to have multiply that by second and matrix here again. And you're going to call upon matrix B, so A times B. So it's going to look something akin to this. Yeah, I do apologize about that. Actually, so it should look something like this on your calculator. I don't know if you guys can see that or not, but that's what you should have on the calculator, just like so. All right, and let's see what our answer should be here. We should get exactly the same answer that we have here on the screen here, which is correct, actually. There we go. I want you to take a look at the answer we got here, which matches exactly what we should get. Okay. Did everybody get the same answer? I hope you did. So just to be on the safe side here, type yes in the chat if you got the same answer as you see on the screen on your calculator. Okay. Missing a few people here. See here, Jenna, JTS. Did you guys get it? Andre? I just want to be sure everybody's kind of on the same page, so. Yes, okay, good. JTS? Andre? Okay, Andre got it, good. Waiting on JTS then. Okay. Maybe JTS stepped away, I don't know. So let me know, JTS, if you are there, then let me know if you went wrong somewhere, and then we can hopefully fix it, so. Yeah, maybe you stepped away. All right, that's fine. All right. Okay, so we got all those. Okay, good. So I'm glad you got the same answer here via the calculator. That's effectively how we can multiply two matrices with each other. Now I'm going to show the other way here as well. Okay, what would happen if instead of multiplying A times B, because that's what this is basically matrix A times matrix B. You know, what would happen if I went in reverse? What if I did matrix B times matrix A? Well, matrix B here would be, again, -1, -2, 0, 7, 11, and 4. And I'd multiply that by, again, our matrix here of -2, 3, 5, and -4. Again, we just go through our 2 steps here. Step 1 is we have to check to see whether we can multiply these together. Again, as we know, this is a 2 by 3 matrix for the first one, 2 rows and 3 columns. And this here is a 2 by 2 matrix. Unfortunately for us here, the number of columns and the number of rows, number of columns in the first matrix and the number of rows in the second matrix, those do not equal each other. So even if you tried it on a calculator, it'll tell you that there's an error. So essentially, this is not possible to actually multiply in this direction. So although A times B is okay, B times A is a no-go, all right? So do understand that there is a distinct difference. Like I said here, A times B is not the same thing as B times A. There is a significant difference between the two. Okay? All right, any questions about that? No? Okay. Good. Well, maybe I didn't submit it. Oh, I didn't. I was like, wait, I thought I submitted this, but it did not. Okay. There we go. All right. Nightbot being little too spammy. All right. All right. So okay, good. Now, that's in a sense the end of section 6.3. Now we're going to get into the last part here, and that's going to be section 6.4. So section 6.4 here is going to be the last section here of chapter 6. All right. Yeah. All right. So let's take a good look here and talk about in section 6.4, the last section here of chapter 6, talks about the inverse of a matrix. Okay, we're going to talk about the inverse of a matrix. So basically put here, we're going to kind of do this the easy way. How do we find the inverse of a matrix? Well, it's actually fairly simple because we do have a goal in mind here. So let's talk about section 6.4 here, number 1. Okay, I'm going to erase this here. All right. So how do we find the inverse of a matrix? Well, here's basically what we want to have happen. We could take a generic matrix here. Let's call it A, B, C, D, E, F, G, H, and I. Okay, so let's say this is just a bunch of random numbers in a 3 by 3 matrix. What we want to have happen is we want to basically take this matrix here. We're going to go ahead and basically augment this matrix. Again, we add a little bit of a matrix here. We add this matrix here. This is the identity matrix. So this is basically, if we wanted to do it, what we want to have happen here. So this is basically what we start with a inverse matrix. And what we want at the end of the day is we want to convert this type of matrix here, and what we want to convert it here to our goal. Our goal here is going to be looking like this, where we have, instead of this being on the right side, this is now on the left side. And then you get new letters here. You could go, again, W, X, Y, Z. All right, W, X, Y, Z. I don't know, let's make them letters here. J, K, L, M, N, N. All right, so this basically means that this matrix on the right here, they're random numbers. But again, essentially at the end of the day, is that A, B, C, D, E, F, if we took the inverse of this matrix here, again, you can label this to the -1 power here, is equal to W, X, Y, and then the Z, J, K, L, M, N. Okay, so again, these are just numbers that just kind of occur. Now you're probably saying, yeah, that's a lot of letters, but really, in reality, the important part here I want you to clue in on is actually what I wrote right here, this to the -1 part. Remember that the notation here specifically, and we're going to exploit this here in this case. Oops. Notation is again that matrix A, A to the -1 power. Okay. So this -1 power here is going to be our go-to guy. All right. Well, let's take a good look here on how we can find the inverse here in this instance. And it's not going to be too hard. Again, what I do expect you to use here is I do expect you to use the calculator here. Okay. Without a doubt, a calculator here will be incredibly helpful. All right. So we're just going to use an example. And again, I want you to use your calculator for this part here. So that way you get comfortable with that idea. Okay. So let's go ahead and use that was brutal. All right. Yeah. There's a couple things I'll need to point out here. All right. Erase this here now. A couple things I'll need to point out here. First of all, how to do that. So let's take this matrix here. We'll call it we'll call this which matrix I want to take. Okay, that's fine. Let's talk about 0, 2, 0, 3, 3, 2, and 2, 5 minus 2, 5, 1 or minus 1. Yeah, positive 1. Okay. So what I would like you to do is to put this in, make a 3x3 matrix in your calculator. Okay, so we're going to go ahead and hit second and the x to the -1 key again. We're going to scroll over to edit, and this time here, just go to matrix A and relabel that as a 3x3 matrix and plug in the numbers that you see on the screen. All right. Now, once you have all the numbers entered in, quit out to the main screen. Hit second in mode. And we're going to go ahead and hit second and the x to the -1 key here again. And this time here, we want to go ahead and hit enter on letter A. And we do want to have the -1 power here. We actually, instead of second and x to the -1, we actually just want to outright hit to the -1. So it should look like this on your calculator here, just like so. Or again, you can use the caret key and -1, whichever way works. All right. Now, let's go ahead and type in, let's go ahead and hit enter. All right, and hopefully you'll get this matrix that I'm about to put up here. Check that really quick. Or you can also put it in fractional format. So here's what I did. I just put it in fractional format if you want, if you like to keep it a little more clean. This can be helpful here if you have like really messy decimals. Then at the very least, you can see how I did that here. Let me move that over. Here we go. You can see that, see what that looks like right there. Is I just pushed the mode key and I hit number 1, which was fraction, and you can put it in fractional format if you feel compelled to do that. Or again, if the homework question or test question asks you to write in fractions, then at least you have that available. Okay, so did everybody get this answer here? Go ahead and type in yes in the chat if you got this answer here. Okay. All right. Good to see you, Terrence. Hope you're doing well, my friend. Yes? Okay, good. JTS, if you're still there, I'll ask again. Yeah, it's been a while since I last saw you, buddy. All right. I understand. Yeah, you got to put in the hustle. Respect. Respect, my man. Respect. You've been putting in the work, so I can't really argue. I see the results, man. They're paying off. That's for sure. Andre, did you get that? Just ask that really quick. Andre? Yeah, no problem. No problem, Terrence, man. Definitely deserve the praise. Never forget that work ethic. It pays dividends. All right. Well, maybe Andre and JTS stepped out. That's fine, though. All right. In any case, all right. All of you got this as an answer here. All right. Now, so this is basically our final answer for this problem here. Now, certain problems here are going to ask you whether or not these two guys here, let's say it gives you a matrix here, and they say, are these two matrices inverses of each other? Well, if you ask here, you're like, well, wait, yeah, of course it is because I just found it. But a way to confirm that these two are inverses of each other is to basically take that first matrix there. If you take this matrix here, if you take this, so if, I guess I'll say if this matrix times this resulting matrix we got here, so let's take, again, minus 7 halves, minus 1, 2, 1 half, 0, 0, minus halves, 2, and minus 3. Okay. Then basically, if I multiply this, then what I should get here on the calculator is I should get the identity matrix here, which is equal to this. Oops, not that. Not that way. Like this. So if you want to confirm that these two are inverses of each other, just multiply it this way, or you can reverse multiply it as well, and you can get the same result here. So again, either way, this is again like, say, matrix. This is like A. This is A inverse. This is matrix I for identity matrix. So you can reverse this around. So again, if A times A inverse equals the identity matrix, and if you reverse it around, A inverse times A is also equal to identity. All right, then this checks out, no problem. All right, so just letting you know, that's how you know the difference here between if those two are inverses or they're not. And again, plug them in, multiply them together. This should work out here on the bottom. That's how we can check. And let me go back here to yeah, okay, that's fine. Okay, any questions about that before we move on? Nope. Okay. To find that, is that? There it is. Okay. All right. Now for a 2 by 2 matrix, and only specific for a 2 by 2 matrix, I'm going to erase this here because I'm going to need this for a 2 by 2 matrix. All right, so let's talk about number 2. What is the multiplicative inverse of a 2 by 2 matrix? Now, unfortunately for 3 by 3 matrices, there's not really a shortcut to find the inverses of those matrices. But for a 2 by 2 matrix, actually, there is a shortcut to actually doing that here by hand if you want. All right, so we're just going to talk about that here briefly. Okay, so if we're given a 2 by 2 matrix here, again, let's call it A, B, C, and D for just random numbers here. The inverse of a 2 by 2 matrix here is going to equal this. It's going to equal 1 over A times D minus B times C times the matrix here of D, A, minus B, and minus C. So this is the inverse here of any generic 2 by 2 matrix will always come out to be something akin to this. So if I had, let's say for example here, let's say I had, let's go with our example here in this case. Let's say I had negative 3, 5, minus 1, and let's call it, I don't know, 4. Sure, 4. That's making stuff up here. So all we need to do here is, if we're going to take this inverse here, is we're just going to plop in the numbers. So again, we have A, B, C, and D. So again, if you want to label this is A, this is B, this is C, this is D. So you get A, which is minus 3, D, which is 4, minus C, BC, sorry, B, which is 5, and C, which is minus 1. And then we just write in D in that spot there, 4. And A goes in that spot there, -3. Flip the signs of the other two, -5 and +1 here, respectively. Go ahead and put this together here. We get -12, so this will be, again, -12. This is +5. So here we get 1/7, and then we just multiply it by this matrix that we have here of 4, -5, 1, and -3. And then just do the same thing we did in the last section, just multiply everything by 1/7. So we're going to get our answer here of 4/7, -5/7, 1/7, and -3/7. All right. And that's our final answer for a 2x2 matrix. That's it. Any questions about that? All right. Let's move forward here with the last question on this handout. I think that's the last question. Yep. So the last question on the handout here, and the last question of chapter 6, is how do we solve a system using the inverse of a matrix? How do we solve the system using the inverse of a matrix? Okay, so what if we're given a system of equations and I ask you, hey, can you solve the system of equations, using the inverse of a matrix as opposed to, doing something else? So reasons. In any case, yeah, we can definitely do that here. All right, so let's look at an example here for number 3, and let's go ahead and met it out. All right. So here we have x plus 2y plus 5z is equal to 2. Here we have 2x plus 3y plus 8z equals 3. And okay. So minus x plus y plus 2z here is equal to 3. Okay. Now, what we're going to be doing here specifically is we're going to actually break this up into multiple parts, okay? So this is going to be a little noticeably different than maybe what we've been doing before. So I'm going to split this up in such a way. I'm going to have a matrix A. I'm going to have a matrix X, and I'll set that equal to a matrix B. And I'm going to label what each one of these mean here, okay? Okay, so let me go ahead and define here what matrix A, X, and B are. Matrix A is going to be all the coefficients, so all the numbers of X, Y, and Z. I can't spell coefficients, so you'll have to run with it. All right. Matrix X here specifically is basically the letter matrix, so it's the XYZ matrix. We're going to physically have an equal sign here, by the way. So that equal sign is designed that way. And matrix B here is going to be our answer matrix. All right, so if we take a good look here, let's define matrix A here. We're going to take all the coefficients of x, y, and z. That's going to be 1, 2, 5, 2, 3, 8, and -1, 1, and 2. So just x, y, and z here will be matrix A. Next, we'll have matrix X. Matrix X is just the x, y, z matrix. So just all in a nice column here. We're just going to go ahead and put x, y, and z, just like so. Okay? No problem. We're going to physically put an equal sign here, just like so. So there's our equal sign. And then we're physically going to go ahead and put in a matrix, our answer matrix here of 2, 3, and 3 here, respectively. Okay? So this here is our setup. We've set up our matrix here appropriately. All right. Now our goal is, of course, to solve for x, y, and z. And so the question is, well, how do you do that? The way we want to approach this is specifically is we want to effectively divide A on both sides. We want to divide by matrix A. But matrix A is not a number, it's a matrix. And you can't necessarily divide by a matrix. The only way you can divide by a matrix is if you take the inverse of that matrix on both sides. So what we're going to do is, and put this in red here, we're going to multiply by the inverse matrix of A here. Okay? And notice, very important here, this is actually one of the important things, so I will make a note regarding this part. So remember, note here, order matters. So A inverse, A to the -1, should also be on the left when putting it on the right-hand side. So this is actually a big deal here. A inverse can't just go anywhere. There is a specific ordering to it. So what that means is that matrix A inverse needs to go over here as well. So what that implies is that if we're going to solve for x, y, and z, it should look like A to the -1 times B. Order matters here, so it's very important that you understand that that's what's going to happen here. So all we're going to do here is we're going to solve for x, y, and z here appropriately. We're going to take our matrix, take that to the -1 power, and then multiply that by the matrix of 2, 3, 3. Again, you're going to need to define each matrix on your calculator, but this should now be easier to do. Again, remember what we have here. This is this first one here is a 3 by 3 matrix, okay? And very importantly for this other one here, this is going to be a 3 by 1 matrix, okay? 3 rows, 1 column, okay? Not 1 by 3, 3 by 1, okay? Rows by columns, remember that. So we're going to enter this into our calculator, defining matrix A as that first one you see there on the screen, and matrix B being your 2, 3, 3 column, as you see right there. And we're going to get an answer here. So again, go second and x to the -1 key and edit your matrix A and matrix B appropriately using the numbers that you see here on the screen. All right, and then I'll go ahead and call upon the matrix here. Take that to the -1 power. And then I'm going to multiply that by matrix B. And can anybody tell me? Let's get a. Hopefully we get a good answer for this one. What do we get for x, y, and z here? What's our answer for x, y, and z here appropriately? Should get 3 numbers here. And let the calculator do the work for us here. What's our answer for this problem? Just looking for an answer here. Do, baby. I'll wait for you guys to give me an answer. Come on, guys. I know you guys can do this. Let's go. Well, I can sit here and play on my phone, while you guys are kind of figuring that out. So hopefully we get the right answer there. But see how it goes there. Come on, one more. That's all I ask. X, Y, and Z, guys. That's it. That's all I ask for. I promise. All right. Well, that's okay. I guess we won't get an answer for this one here. Oh, we got an answer. Yes. All right. -2, -3, and 2 is the correct answer, Planet. Very good. Very good. I don't know why that took a while. That one was but okay. Hey, you guys got to figure that out on the calculator when you guys got to do the homeworks and the test. So, hence why I'm willing to wait. I'm not the one who's got to do the work. It's you. So, I don't mind waiting an eternity if I have to in order to get the point across. All right. Very good. That is the correct answer. All right. So are there any questions about section 6.4? That's pretty much the end of 6.4, by the way. Just letting you know. All right. Now, one thing that is very important here for those who did leave early, then I guess they don't get to hear this announcement here. Since that is the end of chapter 6, by the way, that means that we will be having a test over chapters 5 and 6. Okay, so I'm just pointing that out here. Chapters 5 and 6 will be a test that'll be put here together. Okay, so since chapters 5 and 6 will be its test, I'm gonna be posting that test there and the homework here probably later on tonight because I gotta go to my game. So I'll be posting that here later tonight, but that'll be due. This will be due here on. I'll make this due on the 29th. So that's next Sunday. All right. So I don't want to have it due on Friday, otherwise it interferes with cat Thanksgiving, and nobody likes that. So I'll make it due on the 29th, and in the meantime, we're gonna go ahead and do. So that's the chapter 5 and 6 test. So again, I want you to enjoy Thanksgiving. That's very important. I think family time is super important in a COVID situation. So I think family is super important there. So yeah, just have a chance to relax. Again, I'll be posting the practice test and the homeworks and whatnot. That'll be due on the 29th, and then that'll be good. All right. So we'll be finishing off chapter 7 here. Again, we'll have there are 3 sections to chapter 7. We're going to take it one section at a time just because there's kind of a lot of information in each section, so we kind of have to go a little bit slower over that. But yeah, I'll make another announcement there on Wednesday, and I'll probably post an email there saying, hey, this is due next Sunday. Get this done. Do it. All right, so that's pretty much what's on the agenda here moving forward. All right. Anybody have any more questions? Nope. All right. Okay. Good. All right. So that'll take care of for today, everybody. I want to thank everybody for coming out here for this stream here. You guys, we got 2 sections done, so we're done with chapter 6. Next time, chapter 7. Same time, same place, everybody. Thursday, Thursday, Thursday. Thank you. Thank you for coming out and making an effort to come out to the stream here once again today. So we will see you on Wednesday. All right. Everyone, have yourself a wonderful evening. All right. And we'll see you in a couple days. All right. All right. Take care of yourselves, everybody. Have a great one. We'll see you.